Alright, so we are doing exercise 9E, and this is question 3. It reads as follows. If C and D are events such that the probability of C with a union of D equals 0.85, and the probability of C equals 0.45, and the probability of the complement of D equals 0.37, find the following probabilities. So before we launch into answering these, let's begin by filling out our table. And we have to begin by putting in some letters. So let this be C, and let this be the complement of C. Let this be D, and let this be the complement of D. Now, what have they given us in the question itself, which we can immediately put in here? Well, they tell us that the probability of C is going to be 0.45. So I can get my pen and I can come here to where the probability of C lives and write in 0.45. They also tell me that the probability of the complement of D is 0.37, so I can get my pen and put this here, 0.37. And there's one more piece of information we can immediately put onto all tables, and that is the fact that right here is going to equal 1. Now that's going to be useful for us because we know that these two are going to add up to 1, so that means here is going to be 0.55. This is being the probability of the complement of D. And we can also figure out this, which will be the probability of D, which will be 0.63. So now that we have those values, let's see what else they give us. Well, they give us that the probability of C, the union of D, is going to equal 0.85. Now that's a bit strange because all of these have to do with intersection points. But we know that the union of D, C, the union of D, rather, the probability of C, the union of D, we can use the addition rule to find something interesting. So the addition rule tells us that the probability of C, the union of D, is going to be equal to the probability of C plus the probability of D minus the probability of C intersection of D. Now that we have that, we can put in the values that we know in order to find out what my probability of C intersection of D will be. So let me scroll down a little bit. Now, well, let me begin by saying, what's the probability of C, the union of D? Well, they tell me that in the question. That's going to be 0.85. So that's the very first thing I should write down. Right here, we know that this is going to be 0.85. We know that the probability of C is going to be 0.45, 0.45. And we know that the probability of D, is going to be 0.63. And of course, we're leaving this as is because we're trying to find out what my intersection of C and D will be. All right, now let me scroll down. I don't have to look up anymore. So we could now say that 0.45 plus 0.63 is going to be equal to 1.08. And let me leave this on this side like this. And let me rewrite this again. C intersection of D. Then I'm going to minus 1.08 from both sides. So that will cancel out. And what I'll be left with is now negative 0.23 equals minus the probability of C intersection of D. I would then divide both sides by -1, and what I'm going to end up with is these negatives will go away. So I'm left with that the probability of C intersection of D will be 0.23. Now I come up here and I know that the intersection of C and D will be here. So I can write 0.23 here. Now I can start to fill out other parts. So I could say, all right, what will the probability of C intersection with the complement of D be? Well, it's going to be 0.23 plus something equals 0.45. And I know that's going to be 0.22. Then I could say, well, I know that the probability of the complement of C plus D is going to be this plus this. Sorry, let me say that again. It will be 0.23 plus this value will be 0.63. So that will be 0.4. 0.4 plus 0.23 will be 0.63. And then finally here, I know that 0.22 plus 0.15 will be 0.37. So now I filled out my table, so I could come over here and start actually answering questions. So the probability of D is going to be 0.63. The probability of C intersection of D is going to be 0.23. 0.23. The probability of C with the intersection of the complement of D, C complement of D, will be 0.22. 0.22. And now I need to find the probability of the complement of C with the union of the complement of D. This is where things get interesting because this does not exist on my table. But what we can actually do is use an extension of my addition rule to solve this. So let me just do some cleanup here for a second. Let me get rid of my, let me try again, come here. Let me get rid of my working out here. Well, actually, I don't want to get rid of it. Let me just put it down for a second. I'll get rid of it. I'll put it back later. All right. Just me trying to figure things out. So what I'm trying to find now is this, which is the probability of the complement of C with the union of the complement of D, which will be the probability of the complement of C plus the probability of the complement of D minus the probability of the complement of C intersection complement of D, close brackets. Then I can start filling in some points. I know that the probability of the complement of C will be 0.55. I know that the probability of the complement of D will be 0.37. 0.37, and I know that the probability of the complement of C with the intersection of D is going to be 0.15. So let me scroll down now. So therefore, I could say that 0.55 plus 0.37 is going to be equal to 0.92 minus 0.15, which is going to be equal to 0.77. So therefore, the probability of C complement, the complement of C, the union of the complement of D, is going to be equal to 0.77. So now I can come back up here and write here 0.77. So hopefully you've understood how I got that. What it was an extension of my addition rule. And we have now answered 3A. Hopefully this has been helpful to you. See you in the next question.